For millennia, people have been fascinated by the idea of alien life forms, and with the billions upon billions of Earth-like planets within the Milky Way itself, it leaves us to wonder, where are all of the aliens? In our own Milky Way galaxy lies around 200 billion stars, each with the inherent ability to support its own solar system. Around these, we've discovered over 100 billion planets. Anywhere from 5 to 20% of all these stars are sun-like, and around these, around 40 billion of those planets are Earth-sized and located in the Goldilocks zone, which is an area around the sun, the correct temperature to harbor liquid water, and therefore life. Not too hot, not too cold. And considering that there are over 10 trillion galaxies in the known universe, with up to, well, a lot of stars, the number of habitable planets in the whole universe is a really, really big number. And if the average galaxy has roughly the same number of habitable planets as our own, that puts our chances of being the only planet with life at 1 out of 6 sextillion. That's a 6 with 21 zeros behind it. So why haven't we seen any alien life yet? This is known as the Fermi paradox, named after physicist Enrico Fermi for bringing to light the contradiction between what our probabilities say and what we actually see. And no one really knows why the Fermi paradox exists, but one particularly interesting theory that has been gaining momentum is the Great Filter theory. It states that perhaps the reason that intelligent life is so rare is that there is one big event in its progression that's incredibly difficult or rare, so it creates a barrier in the advancement and expansion of intelligent life. And from this rises a few possibilities for ourselves. Perhaps we, as human beings, are already past this barrier/filter. Maybe the arranging of molecules into self-replicating patterns necessary for life is extremely rare, and we just got lucky. After all, the particular environment and conditions necessary for creating those self-replicating patterns aren't known to us yet. Or perhaps the filter was the jump from single-celled organisms to multicellular organisms. Our lack of evidence of even simple single-celled life on other planets seems to suggest that we've already passed this great filter. But the idea still stands that the filter could be in front of us. Maybe it's something in our near future. Perhaps it's climate change or the depletion of resources before long-distance space travel is invented. Perhaps it is long-distance space travel itself. Maybe the cause of our downfall will actually be ourselves. The inability to cooperate amongst our own species could lead to nuclear war or technology that overtakes us. Perhaps there are many filters, both before us and after us, and the probability of passing each one just gets smaller and smaller as we grow more advanced. Or perhaps there is no major filter, and we are simply the first of many intelligent species to come into existence. After all, the universe is only about 13.8 billion years young. Or maybe we're simply not looking for the right thing. Living on Earth, being exposed to only the forms of biological life that we know today, narrows our criteria for what we perceive as life. So far, we're banking all of our scientific assets and endeavors on finding the type of life that we're familiarized with. The kind here, on Earth. Life that has a need for water, is dependent on an oxygenated atmosphere, at the minimum contains a few specific elements, has cellular organization/structure, has DNA, and reacts with the senses that we have, and etc. But the universe, in all of its vastness and opportunity, could create so much more than just what fits our criteria for life. Life could exist in forms that simply throw away our own established definitions. If we go into this vast, vast universe with preconceived notions of what life is, then there's no telling what we could be missing out on. And though we haven't found any alien life yet, it certainly won't hurt us to keep looking.